This lesson is over Introduction to Functions. A function is a relation such that for each x value, we have a unique y value. Function notation we've seen before in Algebra 2, like f of x, maybe g of x, or h of x, where it's y equals mx plus b in function notation would be f of x equals mx plus b. So it's kind of replacing our y, or our output for every x input. So let's take a look here at determining if a set of ordered pairs represents a function. So we're going to look at x value. Do they repeat? If no, then it's a function. If yes, they must have the same y value to be a function. So, looking at this one here, we want to look at all of these. 5, 6, 7, they're all different. It doesn't repeat, so it's a function. So x values do not repeat. So function. Whoop, whoop. All right, number 2, let's look at those. 7, 6, 5, 7. Uh-oh, we have 2 7s, but let's look at those 7s. So x values repeat. So we want to look at the y values. They are different. They have different y values. They have -3 and 0, which means no good. They shouldn't have different outputs for the same input. So this is not a function. Wah, wah, wah. But if these were the same outputs, and it would be the exact same, like 7, -3, then 7, -3, it would be a function. They have to have that same y value. All right, so let's take a look now, determining if an equation represents a function. So, function if the exponent on the y is odd. So for example, y, because it would have a 1 as its exponent, y to the 3rd, y to the 5th, and so on, okay? Not a function if the exponent on the y is even. All right, so let's see here. Let's look at our y. It's a 1, so odd function. Y, uh-oh, it's even. It's a 2. So it is not a function. Right, so now we're going to take a look at evaluating. Evaluating is plugging the number that's inside there we're going to sub that in for x into our function up here. Okay, so it's going to look like this. F of 1 is 4 times 1, so we're going to replace that 1 in for x. This is just identifying, hey, we're going to use that function, we're going to plug 1 in. This is just kind of identifying what you're going to do. We plug it into our equation there. So 4 times 1 is 4, minus 3 is 1. So if you want to try that next one, go for it, same equation. This time, we're going to plug in a negative 3. So 4 times negative 3 minus 3. So negative 12 minus 3, negative 15 is what you should have gotten. All right, let's take a look at number 2. Number 2, we're going to plug in 3 in for y. So sub in for y. So g of 3 is going to be 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. Now in this next one, we're going to plug that in for y. So g of x plus 1 is taking your x plus 1, squaring it, and then adding 1. Now remember, when you square a binomial there, you're going to take x plus 1 times x plus 1. You don't distribute that exponent. We have to FOIL. Okay, so we have to take first, then outer, and then inner, and then last. So x times x is x squared, x times 1 is 1x, x times 1 is 1x, and 1 times 1 is 1. So this gives me x squared plus 2x plus 1. And then I need to bring my 1 down. And then I'm going to combine to get my final answer of x squared plus 2x plus 2. So on this one, when we are looking at a piecewise, which we're going to look at those a little further into this unit. This is a piecewise function. When we have it negative 2, is negative 2 greater than 0? No. So we're not going to plug it into that one. We're going to plug it into this one because here, negative 2 is less than 0, yes. So we're going to plug it into this top. We're going to use the first piecewise because, so use first piecewise. Because negative 2 is less than 0. So let's go ahead and plug that in. So we're going to take f of negative 2, and we're going to use the negative 2, and we're going to square it. So negative 2 times negative 2 is positive 4, plus 2 is 6. So take a look at that next one, 5. Are we going to use the first or the second? Or both? Is 5 less than 0? Nope. Is 5 greater than 0? Yes. So on this one, you need to use the second piece because 5 is greater than 0. So f of 5 is equal to 2 times 5 plus 4. So we're plugging that 5 in for x into that second one. So 10 plus 4, 14.